Assalamu alaikum, and in this video, I have come back with another uh, problem. And before solving this problem, I have to talk about two things. And one thing is that whatever the problem you're having difficulty in, you just mention the problem in the comments. And I would, whenever, like this problem I'm doing, I would just write the problem number and the author or the book I'm referring regarding this problem. And so that when you search for your required problem in any case, so you must be having easiness in finding that problem, the solution. Okay. And secondly, always before going towards a solution, just give 15 to 20 minutes in solving the problem on your own. Okay, by your brain skills and technical skills, whatever Allah has blessed you. And then what we see is, in this problem, we have American engineering units of viscosity, which is LBF R per foot square, and we have to convert it into the gram per. We have to convert the 20 gram per meter per second into uh, the American engineering systems. Okay, so to solve this problem, we would find a technique, and that technique is the rows in column, the vertical or the horizontal lines technique, and it's very simple. um, what we just first you need to do that we have to make their um, vertical horizontal lines like this. Okay, and according to your requirement you can just make more vertical lines as you wish. Okay, so with this way what we do, that the vertical lines over here means that whatever across this vertical line would in multiplication with each other, and whatever across would be along this horizontal line, whatever across this horizontal line here would be in division with each other. Okay. Now what we have is 20 gram meter second. Okay. So first we want LBF hour per foot square, but we do not have LBF overall here, and it's on the upper side of the division. So we will write LBF over here. 1 LBF is equal to, we know that we must find a relation of LBF with the mass, okay, because we do not have a direct relation with gram and LBF. So we know that LBF is 1 slug fit per second square. And we know when we have a division over division, what happens, it just shifts towards upper side, okay, like this. I'm removing the second square and the division and putting the second square over here. Okay, then what we're going to do is converting the slug into the grams, finding a relation between slug and gram, and we know that one slug is equal to one slug is equal to 14.59 kilograms, right? And we know that 1 kilogram has 1000 grams. Okay. Now, similarly, with this done, we see that slugs cancel with slug, gram cancels with gram, kilogram cancels with kilogram, and we have a LBF remaining over here. And we see that this second over here is cancelling with second square. So we can minus 1 power and cancel this second. Now we have 1 power left in the second side. So we have to convert this second into the hours. And how would we convert that? We know that hours in the upper side. So we will write to cancel the second. To cancel the second, we would write the second in the division corner. Okay. To cancel this second, we would write it in the lower corner because across this horizontal line we have division. So we know that 1 hour has 3600 seconds. So second and second would be cancelled, and what would be remaining is with hour. Now, what is left to convert? We see they are one fit power, but we do not have another fit power because in division it's fit square, not fit. But we know that there is 1 meter left in the division side. So what we would do, we would convert this meter into feet. So to cancel this meter out, we would put it in the upper side of the horizontal line so that meter and meter cancels. And 1 meter is equal to 3.28 feet, right? So meter would be cancelled with meters. And what would we be remaining is with LBF R feet square. So we see that 20 gram meter second is equal to, by calculating all the variables above, we would find that it is equal to 1.16 10 is to power minus 7 lbf r per feet square, right? So one thing which is to be noticed that a very small value in bigger engineering unit system. So when you have bigger engineering system units, you have a small numerical value. And then you have smaller engineering units, you have a comparatively greater numerical value. Thanks, and tell me in the comment section that what problem you want to be answered next. Thanks.